Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Killer Ratio by J.C. Goddard. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Digits cannot repeat within cages. Orthogonally adjacent cages have sums in the 1 to 2 ratio and cannot share any digit. So orthogonally connected adjacent cages is basically just meaning cages that share an edge. So this cage is orthogonally adjacent to this cage and this cage. And remember, cages that share an edge have sums in a 1 to 2 ratio and cannot share any digit. So for example, these 4 digits have to be different than all 4 of these digits because this is in a they cannot share the digits between orthogonally adjacent cages. And this is the killer part of the killer ratio because these are killer cages that these are known of. And again, you cannot have repeats within cages. That's normal killer cage rules. In addition, digits joined by a black dot are in a 1 to 2 ratio, and not all dots are necessarily given. So for example, if this was a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. And these are called Kropke dots. But the ratio part looks like it comes from the cage sums, which have their sums in a 1 to 2 ratio, and the black Kropke dots, which have to have a 1 to 2 ratio also. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this is in a 1 to 2 ratio with both of these. So this is 1 through 9. But it cannot be 1, because if it's 1, then this has to add up to 2 at most, which obviously 3 unique digits have to add up to at least 6. So this can be 3 through 9. This is at least 6. So it's 6, 8, 10, 12, 14, 16, or 18. Well, we know this, whatever this sum is, has to be in a 1 to 2 ratio with this. Okay, I'm not sure what that tells us. This is in a 1 to 2 ratio with this. So this is equal to 3 times something, right? Whichever one of these is smaller, these are equal to 3 times that. So therefore, this digit must also be 3 times something, right? Because if you have something that's divisible by 3, and you sum it with something else, and it adds up to something that's divisible by 3, this digit then must be divisible by 3, right? So say the x in this case was 12, right? If this was 12, then you would have 12 times 3, which would be 36, and 45 minus 36 is 9. So they're all divisible by 3. So this has to be divisible by 3. So it must be 3, 6, or 9. Again, this is in a 1 to 2 ratio with this. So this is 2x of this. This cannot be half of this, because if this is half, this would have to be 19. Or sorry, if this is half of something, it would have to be at least 10, which would force this to be 20. But then 20 is more than double of 9. So that's not possible. So this is in a 1 to 2 ratio with this. So this is 2 times. This is 1 times. This has to be 4 times whatever this is. This, again, this is also in a 1 to 2 ratio. So basically, one of these is 1x, and the other one's 2x. So similarly here, this has to be 3 times something, right? It has to be divisible by 3, because this is already divisible by 3, right? So it's either 42, 39, or 36, in which case this also has to be divisible by 3. Well, cannot be 9, because 9 cannot be in a 1 to 2 ratio with anything, because 9 is not double any in a digit, and if you double 9, you get 18, which is not a digit. So this has to be 3 or 6, which forces this to be 3 or 6. So now we have a 3, 6, 3, 6 pair here. So that means this x, whatever this x is, that's times 3, has to be either 39, which would make this 13. So the total is either 39 or 42. If it's 42 divided by 3, that means this is 14. If this is 39 divided by 3, that's 13. But if you have this being if you have 13, the other one's 26. But if this is 26, this cannot be 52. If this is 13, that would force this to be 26, which would force that to be 13, but then this would be 6.5. So that's not allowed. So this almost certainly has to be 14 as the value, which means this has to be 28. So this has to be 3, and this is 6, right? It's 3 in the corner. We celebrate because we got our break-in. This is 4 times something. This has to be 2 times something. If this was 8 times something, well, none of them can be, right? It's 14 or it's 28. It can be at most 4 times something, but it's not, right? So this has to be 2 times something. This can't be 8 times something, so it has to be 2 times something, which makes this the 4 times something, which makes this, it cannot be 8 times something, right? Because again, the 4 times something is 28. 8 times something would be 56, so this has to be 2. So this adds up to 28. This is 14. This is 14. This is 28, and this has to be 14, which forces this to be 7. So this also has to be 14 that adds up to it. This is 28 without a 6. So it's 4, 7, 8, and 9. So this has to be 4, 7, 8, 9. Therefore, this has to be 1, 2, or 5, and this is 1, 2, or 5 here. And this adds up to 14 without a 3. Okay. This adds up to 14 without a 3. This adds up to 14. Sorry, this adds up to 14 with 3 digits. Sorry. This cannot be 1 to 2 because I would eliminate 2 possibilities for these 2 cells, which would make both of them 5. So this could be 2, 4, 3, 6, or 4, 8. We don't know which. This again is, this has to be 14. So if it's 1, 5, if this is 1, 2, it has to be 4, 8, or 5, 7. No, it's 4. This is 14. It would be 4, 7 then. If it's 1, 2, it has to be 4, 7, or 5, 6. So this would be 4 and 7 if this is 1, 2. Or it could be 5, 6. It cannot be 3, 8. Or if this is 1, 5, that would force this to add up to 8. So it would have to be 2, 6 here. If it's 2, 5, that's 7. Therefore, this would have to be 1, 6. So either way, 1 and 2 have to be here. This could be 4, 5, 6, 7, 8, and 9. No, this can't be 7. So this would have to be the 7 if that's the case. Right, 5 and 7 there. So 4 cannot be here. 4 is only if it's with 7, right? So therefore this is 4 and this is 7. I had it backwards. This adds up to 14, so this is 1 through 8, and this cannot be 6. Okay, so where is this digit? This digit cannot be in the same cage, obviously. Can't be in any orthogonally adjacent cages, so it can't be any of this. Can't be this because of Sudoku, so it has to be one of these two cells. We're not sure which. What else do we know? This cannot contain a 7. This cannot contain a 7. Oh, this can't have 4, 7, 8, or 9 either. So how do you add up to 14 without 4, 7, 8, and 9? You cannot have 1. I think it only can be 3, 5, and 6. Yeah, it has to be only 3, 5, and 6 because if you take the highest most, right, 5 and 6, you have to have 3 with it. And that's the most you can have without 4, 7, 8, or 9. And therefore that adds up to 14, which is what we needed to add up to. This is 5, this has to be 3 and 6. Therefore, this can't be a 3, 6 pair because that would eliminate all possibilities for that cell. This can't be 5, so this is 1, 2, which means this can't be 1 or 2. It's either 4, 7, or 5, 6 here. These cannot be 5. This can't be 3, 6, or 7. There is no 7 here. What can you add up to? You can only have 1 out of 3 or 6, and that would have to be here because of the 3, 6 pair. This has to be 1, 2, 4, 5, 8, or 9. So it could be 1, 9, in which case this is 4. 2, 9, in which case this is 3. 4, 9, in which case that's 1. It cannot be 5, 9. It could be 1, 8. But then that would be 5, so that's not possible. It could be 2, 8, which case that's 4, which works. It could be 4, 8, in which case this is 2. Or it could be 5, 8, in which case that's 1, so that works. So those are the 8s and the 9s possibles. What about 4, 5? It cannot be 4 and 5? No. Or actually, yeah, it could be 4 and 5, which could allow this to be 14, which would, no, it would have to be 4, 5, and 5, which is not allowed in the cages. What about 2, 5? 2, 5, I think does work. Oh, this can't be 4 or 7, so this has to be 5 and 6. So the 5 and 6 cannot be here. This has to be 4, 7, 8, and 9. This cannot have a 4, 7, or 8 because of the 4, 7, 8, and 9 that it's orthogonally adjacent to. It cannot be 1, 2, 3 in anything because that would have to be 1, 2, 3, 8. So it has to have 5, I believe. I think the only possibility is 1, 2, 5, and 6. To add up to 14. Yeah, because 2, 3, 5, 6 is too much. 1, 3, 5, 6 is too much. It has to be 1, 2, 5, 6. So this is 6. This can't be because of the 5, 6, 5, 6 pair. This can't be 5. Therefore, this is forced to be 5. This could be 1, 5, and 8. That's, yeah. 1, 5, and 8 is a possibility. 2, 5, and 7 works. Oh, but can't have a 7 because this cannot be 7. So one of these two is a 7, actually. Actually, I guess one of these 3. Or, again, it can't be 4, 5. So we tried that. If it's 2, 4, it has to be 8 here. If it's 1, 4, it could be 9. So that could be the case. And it cannot be 1, 2 here to add up to 14. Okay, we can remove the 7s then. We know one of those 3, but that's a lot. These cannot be 1, 2, 5, or 6. So one of these has to be 3, and the other one has to be a 4 or 7. So this is 3, 4, or 7. And this has to be the other one too, right? Because it can't be here, can't be any of these, can't be any of these. It must be here. So this must be the same as this. Which means this cannot be 1 or 2. This can't be 9. How did I get... Oh, the 9 was... Yeah, it had to be 9 here. Right. So the remaining digits here are 3, 4, 8, and 9. 3, 4, 7, 8, and 9. Right. And this can't be 7, so this is 3, 4, 8, and 9. Because of the 1, 2, 6 triplet here. Actually, this could be 8 or 9 here. We don't know. Right, so whatever this digit is, has to be one of these two. We don't know which. It must be the same as one of these two. The 3 is here, and one of these is a 3. This can't be 3. So this is also 4. We have a 1, 2, and a 4, 7, 8, 9. And this can't be 7. So either way, we know this has to be 4 with 2 or 4 with 8. So 4 has to be one of these two digits, which means this can't be a 4. None of these could be 4. This is in a 1 to 2 ratio with this, which is in a 1 to 2 ratio with this, which is in a 1 to 2 ratio with this, but we don't know what that 1 to 2 ratio is. This cannot contain 3, 6 here. So this has to be 1, 2, 4, 5, 7, 8, 9. And this can't be 5. One of 3 or 6 is here. That means one of 3 or 6 has to be here. Whereas the other 3 or 6, it must be here. So this has to be a 3 or 6. Because this can't be 3 or 6. Because of the 3, 6, 3, 6 pair in the box. Where else can it be in the column? It has to be here. This can't be 4. What can this be again? If this is 3, this adds up to 11. So it could be 2, 9. And that's it. So if this is 3, this has to be 2, 9 here. Add up to 14. If this is 4, this adds up to 10. So it's 1, 9, or 2, 8. If this is 8, this adds up to 6. So it's 1, 5, or 2, 4, and those both work. If this is 9, this has to be 1, 4. Okay. So we know specifically this is 3 or 6. Whatever this is must equal the same as that. So this is 2, 4, or 8. This, whatever this digit is, cannot be any of these, can't be the cage, can't be any of the corresponding ones. Right? Because anything orthogonally adjacent to it, it cannot share a digit, right? And this one shares a digit, shares an edge with this cage. So this cannot be the same as this. These can't be the same because of the same reasoning, and this can't be the same because of Sudoku. These can't be the same because of cages. So these are all ruled out. So therefore, this green must be here. So this cannot be yellow. This is the green. This yellow matches this yellow then. So this is also 2, 4, and 8. Interesting. So whatever this green is has to be here. This yellow has to be here. So this is in a 1 to 2 ratio with this, which is in a 1 to 2 ratio with this, which is in a 1 to 2 ratio with that. Not really sure what that is, though. Okay. Again, the n here, or the x here, I guess, it would have to be either 12, which multiplied by 3 is 36, and this would be 9. 13, which when multiplied by this could be, multiplied by 3 is 39, which makes that a 6. Or this is 14 as an x, which multiplied by 3 would be 42, which would make that a 3. If this were 13, so this can never be 13. This could be 12 or 14, and that works. If this is 12, this could be 6 here. If this is 14, this could be 7 here. So that's the only cases where those can be 12 or 14 specifically. Otherwise, it can't be 13 because this can't be 26. This cannot be 24 or 26. So this is specifically could be 6. Could be 6 in value, could be 7 in value, right? If this is 12 or 14. Or if this is 24, 26, or 28, this is 12, 13, or 14. Right? So this is specifically 6 or 7. And if that were the case, this would have to be 1 and 2. And this would be 3 or 4. It cannot be 2 and 4 this way, and that's 1. Because then that would break. Well, I guess this could be 4 here and 2 here. And that could be 1. So that's if it's 6 or 7. Then you also have it adding up to 12, 13, or 14. If it's 12, it cannot be 3, 6, or 4, 8. It could be 2, 4, though. 2, 4, and 6. It could be 1, 2, and 9. So it could be 2, 4, and 6, or 1, 2, and 9. If it's 12. If it's 13, it would have to be 3, 6, and 4, which works. It could be 4, 8, and 1, which works. Or 2, 4, and 7, which works. And if it's 14, it can't be 1, 2. Could be 2, 4, and 8. 3, 6 works with 5. And 4, 8 works with 2. So this could be all of them. That's not great. Okay. We know this is 4. What's the ratios here is the question, right? Oh, this is in a 1 to 2 ratio too. And again, this one has to match this. So essentially this case you can view as these 4. And this has to be this cage you can view as these 4, right? So we have 2 cages, which one of them is in a 1 to 2 ratio with the other. Therefore, this whole thing then is divisible by 3, which forces the other one, this to be divisible by 3. So this cannot be 3 and 6. So it has to be 9. So this is 9, which means this cannot be 9. So this is 3 or 6. This then is in a 1 to 2 ratio, and the ratio is 12. The sums have to be 12 and 14. Sorry, 12 and 24. Okay. Well, if that's the case, can this be 24? This actually could be 24, so then this could actually be 12 here. If this is a 12, it has to be 1, 2, 3, and 6. The 24 in this case would then be 4, 5, 7, 9. If this is 4, 5, 7, 8, which would be 12 plus 12, right? If this were the 12, it cannot have 3 and 6 twice, so it would have to be 1, 2, 4, and 5. So this is 12 or 24. Actually, I guess it could be... No, it can't be 6 because that requires a 3. This could be 6. So this is 12 or 24 also. If it's 24, it's obviously 8 and 7, 9, which would force this to be 8. It would have to have 3, 6, 3, 6. So this is the, I don't know, we'll make that the pink one. This has to be the pink one. The pink one has to also be one of those 2. And I don't think it can ever be part of this one, right? If it is, that's problematic. Right? Because you have a 3, 6 here and a 3, 6 here. But anytime you have 12 with 4 digits, it has to be 1, 2, 4, 5 or 1, 2, 3, 6. So this can never be pink, which means this has to be the pink. So this is always 3 or 6. If this is a 12, this is 1. This would have to be 2, and this would be 3, 6, 3, 6. So this would be 2. This would be 2. This would have to actually add up to 12. And it would have to be 1, 9 here if that's the case, right? Because you have 2 here. So, okay, yeah, we're doing, so this would be, so if we're doing 2, this would have to be 4. This would be 10 added together, and it cannot contain 2, 8, 3, 7, or 4, 6. 2 because we already have a 2 in the cage, 3 and 6 because we have a 3 and 6 pair in the box. So this would have to be 1 and 9. This can't be 1, so this would be 9. That would be 1. If this is 12, if this, then this would be then 5, 7, 8. We know 9 can't be here. So this would be 5, 7, 8. And this would be 4. So that would force this not to be 4. Except that we have a problem. Because if that's the case, this would be 2. This would be 1. This would be 1. And we have a 1 here. But where is the 1 in column 1? Can't be anywhere, right? Because this would be 1 and this would be 1. So this can never be 12. This actually has to be 24. Which forces... This is 24, so this right now is 3 and 6. That's 9. 24 minus 9 is 15, and therefore it cannot have a 9, so it must be 7 and 8. So this is 7 and 8. Therefore, this is in a 1 to 2 ratio, so this must be 8, which makes this an 8. That makes this a 4, so this is a 4. This has to be 7 here, and therefore this has to be 1, 2, and 5. This must add up to 24 or 6, but this is 8, so therefore it cannot be 6, so it has to be 24. So this is 7 and 9. This can't be 4. 8 is here, so this can't be 8. We have a 7, 9, 7, 9 pair in the column, so this must be, cannot have 7 and 9 in the rest of the column, so this must be 1 or 2. The rest of this is 1, 2, 5, and 8. Well, 7 cannot be, this is 7, so that can't be 7. So this is 9, which makes that a 7. This 7 means this can't be 7, so this must be a 9. This can't be 7 or 9, so now we have a 4, 8, 4, 8 pair here. This can no longer be 9, this can't be 9, and this can't be 8. We have a 4, 8, 4, 8 pair in box 1, which eliminates 4 and 8 from the rest of the box. So this must be a 7. So this can never be 9 anymore. To be one of those. 8 has to be one of these two, so this can't be 8. This is 24, so this must add up to 12 without a 3, a 6, a 7, or 8. So I think that has to be 1, 2, and 9 then. Right? Otherwise, can you get 12 from anything else? No. Without a 3, 6, 7, or 8? No. We still don't know what this is. This then, the n here has to, or the x here has to be 13 or 14. This cannot be 4 here. So this is either 1, 2, or it's 3, 6. Okay, so this can't be green, obviously. This orange has to be one of these two. We don't know which. 7 is one of these cells. Oops. What else do we have? 8 is obviously one of these two. Let's remove the gray because that's not helpful. We can remove the green also. We can remove the yellow now, so the 8 has to be one of these 3. What are the remaining digits in box 8? It has to be 3, 4, 5, 6, 7. This can't be 7. This can't be 4. This can't be 3 or 6. This can't be 9, so one of these 2 is a 9. Which means one of these 3 is a 9. This can't be 7 here. So we have a 1, 2, and a 4, 5 left. So this is only 3, 4, 5, 6, and 7 left. What does that mean? It could still be... Okay, 6 is no longer possible. Because if it's 6, this would have to be 12. But we can't have 12 and 14 here anymore because this can't be 9. Sorry, 12 and 24 here. Because that would add up to 36, but then that would force that to be 9. So that's not possible. So it cannot be 1, 2, 3. And if this were 3 here, it would have to be 1, 2 specifically here. Because 3, 6 is eliminated because you can't have duplicates within cages. So this can't be 3. If this is 6, again, this would force this to be 1, 2, which would add up to 9. But 9 doubled is 18, and 9 can't be halved, and this can't be 18 either way. So this can't be 6. So it could be 1, 2, 4, in which case this is... this would be 7, and this would be 14. And that's the only 1, 2 that works. Can it be 3, 6? It could be 3, 6, 4, because that adds up to 13. Or this could be... Right, so if this is 3, 6, this is 4, that's 13, which would force this to be 26, which would force this to be 13, which works, because then that would be 6. If this is 5, it could be with 3, 6, because then you could have 5, 3, 6 adding up to 14, which would force this to be 28, which forces this to be 14, and this would be 3. So either one of those works. So this can only be 4 and 5. If this is 1, 2, this has to be 4. If this is 3, 6, it could be 4 or 5, and 7 doesn't work with either. 7 with 1 and 2 adds up to 10. 7 with 3 and 6 adds up to 16, which doesn't have a 1 to 2 ratio with either 13 or 14 or 26 or 28. So this cannot be 7. We now have a 4, 5 pair in box 8, which eliminates 4 and 5 from the rest of the box and the rest of the column. So this can't be 4, 5. This can't be 4, 5. And this can't be 4, 5. This can't be 4. This can't be 4. Okay. The rest of this row has to be 1, 2, 3, 6, 5, 6, 8. 1, 2, 3, 5, 6, 8. This can't be 8, obviously. 3, 5, 6, 8. Right. Hmm. So pink has to be one of these two. We're not sure which. Red can be any of these three, though. What else do we have? Okay, this can't be 5. That's interesting. Wait. If this were 1, 2, 4, this would be 7, and this would be forced to be 14. But again, you can't, adjacent cages, orthogonally adjacent cages can't share any digit. What would be the minimum here then? This would have to be 3, 6. It would have to be 3, 5, and 6 and 7, which is already much greater than 14. 5, 6, 7 is 18 already. So this can never be 1, 2. It has to be 3, 6. So this can't be 3, 6. This can't be 3, 6. Therefore, this is 13 or 14. So this is 26 or 28 without a 3 and a 6. So the other 3 or 6 has to be here. And it's 13 or 14. Well, 13 and 14 cannot have a 9, so this can't have a 9. 26 cannot have a 1, and 28 cannot have a 1. So it cannot have a 1, so this can't be 1. So if it's 2, it has to be 26 and 2, 7, 8, and 9. If it's 4, So again, this is 13 or 14. Can it ever have an 8? 14, yeah, it could be 1, 2, 3, 8. But then this would have to be, this would be 6. This would have to have 4 and 5, which is not allowed because we know one of 4 or 5 is here. So this can never have an 8, which means this must be an 8. So this is 8 and 9, so that's 17 already. It could be 2 with 7, 9. So this is 9. It could be 2, 7, 9, which adds up to 26. Then this would be 1, 3, 4, 5. This would be 2. This could be 1, 3, 4, 5. So this would be 2, which would mean that was a 1. So this would be 4, 5. And this would be 1, 3, 4, 5 if that's the case. If this is 4, that means this is 3, 5, and 6. Therefore, this has to be 28. Therefore, this is also 7, 9. So either way, this is 7, 9. So we have a 7, 9, 7, 9 pair. If this is 4, 7, 9, this has to have a 5, a 1, and a 2. And then I think it has to be 6, right? Yeah. This is 4, this is 5. This would be 1 or 2. And this would be 1, 2, 5, 6. So either way, this has to be 7 and 9. So this can't be 7, which forces one of these to be red also. So this is a 7. This can't be 7. This can't be 7. So this is 8, which means this can't be 8. So we have a 4, 7, 9 triplet in box 3, which eliminates 4 and 7 in the rest of the box. These can't be 8. So we have a 3, 8, and 9. This can't be 8. This is a 3, 8 pair, which eliminates 3 and 8 from the rest of the row. So this must be a 4, which makes this an 8. This is a 3, 4, 9 triplet. Therefore, this can't be 4. Cannot be 4. Therefore, this has to be a 7. So this is a 7. This can't be 8 here. This has to be 1, 2, 3, 6, or 9. This cannot be 3 or 6 because of the 3, 6 pair here. So the red 3 or 6 is here. I'm not sure which. Okay, what do we have here? We know 3 has to be one of these 3 cells because it can't be here and it can't be here. Other than that, kind of limited. What can this be then? So if this is 1, can it be with 3? No. It could be with 4. So 1 and 4 would make that a 9. That's possible. And it could be 1, 9, and that's 4. So that's possible. If this were 2, can it be with 3? Yes, because then it could be 2, 3, 9. It could be 2, 4, 8. That works too. And if it's 2 and 9, this is 3, but it can't be 3 here. So that doesn't work as a 2, 9, 3. If this is 9, this is 3, this can be 2. If this is 9 and this is 4, this can be 1. So those are the only possibilities now. If this... This orange cannot be any of these cells, so it has to specifically be one of these 2. We don't know which. It also has to be one of these 2, right? Because it cannot be, it has to be one of the 1 or 2s. Therefore, it cannot be here. It has to be one of these 2. We're not sure which. I'm going to pause because I need to go to the bathroom right now. I'll be right back. And I'm back. Okay, let's continue with this puzzle. Let's see. What do we have? So we have, this is 14, this is 28, this is 14. So this is all solved here. This is 14. What else do we have? If this is 2, 8, 7, 9, this is 1, 3, 4, 5. That seems fine. If this is 4, this is 5. This would then be 4. Okay, so if this is 4, 8, 7, 9, this would have to be the 1, 2 that's orange. And the other 1, 2 would be here. And it would be with 6, and we would have a 5. So this would be 1, 2. This would be 1, 2, 9. This would have to be 5. So this cannot be 1, 2, 9, or 5. So this would have to be a 6 here, if that's the case. So this can never be 6 here, right? Either this is 2, 8, 7, 9, which would force this to be 1, 3, 4, 5, which would force that to be 6. Or this is 1, 2, um, 5 and 6. But this would have to be the orange 1, 2, because that's the only place where it could be. Therefore, this would be 1, 2, 9 triplet, which would force this not to be 1 or 2, because this is 1 or 2, and this would be a 1, 2, 9 triplet, which would make that 5, which would obviously make that 6. Okay. Interesting. Where is this one then? So we're going to make that green. This one obviously has to be one of those two. It has to be one of these two here, right? So this is green, which forces this to be the green. We don't know which. Because of that, it cannot be the green cannot be here. So the green actually has to be one of these two. Okay. Mm. Mm. The green has to be one of these, and the orange has to be one of these. We just don't know which one. Mm. If this is 1, 3, 4, 5, 3 has to be one of these two. Because it can't be here, it can't be here. So this would be 6. This would be 6. This would be 3. That's fine. Oh, this can't be 3. Interesting. Oh, this can't be 9 and 3 here. Because, so this cannot be 2, right? Again, what are the possibilities for this cell? If this is 1, this could be 4 and 9, or 9 and 4, obviously. If this is 2, it's 3 and 9, or 3 and 9. Or it could be 2, 4, and 8. Which adds up to, this can't be 3, specifically. So again, 1 forces this to be 3 and 9. Sorry, 1, 4, and 9. And either of those are 4 and 9. 2 forces this to be 3 and 9, or 4 and 8. Cannot be 9 here. And 9, so either way, well, it could be 4 and 8. We know one of these three is an 8. I'm not sure which. If this is 9, it cannot be with 3. So it would have to be specifically with 4 and 1 then. Okay. Then if that were the case, this would be 9 and 1. This would have to be the blue, sorry, the green 1 or 2, which would be 2. Hmm. Hmm. Okay, so what if this is 1, 2, 5, 6? Then this is the orange 1, 2, which forces this to be the orange 1, 2, which means this is 5, so this can't be 5. So this is 1, 2, 1, 2. This becomes a 5. One of these is a 1 or 2. The orange 1 or 2 has to be here, which forces one of these to be the orange 1 or 2, and it would have to be that one. Okay, can this ever... Hold up. This always has to have a 1 or a 2 here, right? Because you can't have 3, 4, and 9, or 3, 4, and 8, um, adding up to 14. No. And you can't have a 7, obviously. And it has to have 1, 2, or 9, and 3, 4, and 9 be one of the possibilities. So 3, 9, and so therefore this is always a 1 or 2 here. So this could be orange, or it could be green here. So if this is 9 and this is... So either this is green or this is orange. The only time this is orange is if this is 1. Because this can't be 9, 3, because that would eliminate both possibilities here. You could have orange be here, which would force orange to be here, which would mean this is orange here. Maybe we should just go through the possibilities, right? So, if this were 1 and this were... Oh, well, this can't be 4 because that would mean this is not... Well, okay. No, this could be 9, so therefore this would be 9. So that's fine. So this would be 9 in that instance. If this is 1 and this is 9, that would force this to be 3. This would be 6. This would have to be 9 then. So that works also. If this is 2, it could be 4 and 8 here. So therefore this would be 2. One of these would be 2, so therefore this would be 2. This would be 1, which would force this to be 1. Yeah, let's go through the possibilities. So if this is 1, I mean, these all could be green. This would be 1. This would be 2. 2. So this couldn't be 2. One of these is 1, so this would not be 1. This would not be 1. It would have to be 4 and 9 here specifically. So this would not be 9. Therefore, this would be 9. which would mean this is not a 9. One of these would be a 9. This can't be a 1. This can't be 2. So 1 would be one of these. This could no longer be a 2. This could not be 2. This seems like it works okay. This can't be a 2 anymore. This is 3, 5, 6, and 8 as a possibility. 3, 6, 9 here. That's fine. 1 cannot be here anymore, so 1 is one of those two. 1 is one of these two, so this could not be a 1, which would force this to be 6, which would make that a 1. Okay. So the only way this is 1, 6 is if this is 1, obviously. Then one of these would have to be 1. If this is 1, this could be 9, but the problem is it can't be 2, 3, 9 here. So it would have to be 9, 4, and 1. So this couldn't be a 1. So the only case this is 1 is when this is 1. So then this becomes 4, 9. And we showed that this can't be 1, so one of these two is a 1. One of these is a 1. Therefore, if this is ever 1, the 1 has to be here. So this can never be 1. Okay, that's kind of convoluted, but sure. So this can never be 1 as a green. So if this were 1, the problem is this would be 2, this would be 9, and then this would have to be 4 and 1, which doesn't work. So this can never be 1 here. It's 2, 3, 6, or 9. Okay. If this is 9, this has to then be 4 and 1, because this is 3, this would be 9, which would force this to be 9. This would be 2, this would be 1, so that would be 4. Therefore, this would be 1, 1, this would be 2, this would have to be 2, this would be 6, this would be 3. This has to be then 5, this would be 8. This would be a 1, 2 pair, so this could not be 1. This would be 2, this would be 1. Ah, and then we break. So this can never be 9. So that's, yeah. That's what I was hoping to find. I was hoping to find a contradiction here, and we did, right? This can't be 1, this can't be 1. This has to be 1 both times. So then we know this can never be orange. This can't be 9, right? So this must be 1 or 2. This can't be 1, so this can't be the orange. So this is green, so therefore this can't be green. This can't be 2 then. This can't be green, so one of these is a green. If this is 4, we know this has to be the orange. And this can't be 4, so this must be 5, which makes this a 4. Wait. Oh, that's a contradiction there. So if this is 4, this becomes 5, but then that forces this to be 4. So that's the contradiction there that we were looking for. Okay, so this can't be 4. This has to be a 2. And we don't know if it's orange or whatever, but this must be 1 then. which means this can't be 1. So this has to be 2, 8, 7, 9. This must be a 4 then. This must be a 5. This has to be a 4. So none of these can be 4. None of these can be 2. This can't be 6 anymore. So this is 1, 3, 5. This has to be 6, which makes this 3, which makes that 6, which makes that a 3, which makes that a 6. This cannot be 2 because of the 2, 9 pair. This can no longer be 1. We know one of these 2 is an orange. This can't be 4. Okay. What does that tell us? I'm not sure. 2 has to be one of these 2. Right, we did try this being 4, which make that 5, but that makes that 4, which breaks that. This can't be 2. So this is 1, 6, or 2, 6. 8 cannot be here. 4 cannot be here. This could be 2, 4, 8, or 1, 4, 9, or 2, 3, 9. So if this is 1, it has to be 4, 9, which means this has to be 2. If this is 2, that means the green has to be a 2, and therefore this has to be 2. So either way, this has to be a 2. So this is 2, then this is 9, which means this cannot be 9. This can no longer be 2. One of these is a 6, so this can't be 6. And this can't be 6. This has to be... We have 1, 2, 3, 4, 5, no 6. It could be 9, and this could be 8. But this can't be 1 or 2. So this cannot be orange. So that means orange has to be one of these 2. Green could still be any of these 4. So if this is 4, 9, right. This can't be 9. This is 3 or 4. We're not sure which. So what are the possibilities? It's 1, 4, 9, which means this could be 3, 5, or 8. We don't know. So it could be 3, 5, or 8. It could be 2, 4, 8, in which case this has to be 9. Or it could be 2, 3, 9, in which case that's 6, this is 5, this is 8, and this has to be 4. Hmm. Well, we got all the reds. We got all the pinks. We're still kind of confused about the greens and the oranges, though. Orange cannot be here, but orange could be any of these 5. Orange could be any of these 4. Green has to be one of these 2. Oh, this can't be 6 anymore, so this has to be 2, which makes this 6. Therefore, the green is 2. Okay, there we go. So therefore, this is 2, which makes that a 2. This is green. So it's not orange. This can't be green. And this is a green. So none of these can be green. Therefore, this is orange. This is 1 then. This is 1. This is 1. The 2 can be with 3, 9, or 4, 8, but 9 cannot be here. Because if this is 9, the problem is this can't be 9. And sorry, this can't be 3. So this was 3, 4. It's with 8 or 9 here. You have a 3, 4, 3, 4 pair now in row 3, which eliminates 3 and 4 in the rest of the row. So this can't be 3 or 4, so it's 9. This can't be 9. We have a 3, 6, 3, 6 pair in box 5, which eliminates 3 and 6 from the rest of the box. Also, we have no 2 then in box 5. So one of these is 1. One of these is 2. That means this has to be a 1, 5, 1, 2 pair. This can't be 1, so this has to be 5, which makes this a 3, which makes this a 5. This can't be 1 or 5. This can't be orange. Well, this can't be orange, so therefore this has to be the only remaining orange. So this is 1, which means this can't be 1. It's not orange. This can't be 1 or 2, so this can't be the green, which means this is the green, so this is 2. This is orange and green. We don't know which one's which. We have a 1, 2, 1, 2 pair here, so this can't be 1 or 2 in this column, so this must be a 5. These can no longer be 5. This is either 2, 3, 9 or 2, 4, 8. If it's 2, 3, 9, this becomes 6, this is 5, this is 4. If this is 2, 4, 8, then this has to be a 9. So if this is 2, 3, 9, that makes this 6, that 5, and this has to be a 4. If this is 2, 4, 8, then this becomes 5, 6, 3, and this is a 9. So either way, 8 cannot be here. This is a 5, 8, 5, 8 pair here. This can't be 3, so that makes this an 8, which makes this a 3. Remaining digits here are 6, 7, and 9. Well, this can't be 6 or 7 here, so this must be a 9 then, which makes this a 7, which makes this a 6. This 6 means this can't be 6, so this is 3, which makes that 6, which makes that a 3. This 9 means this can't be 9, so this must be 8, so therefore this must be 2, 4, and 8, which makes this a 5. That makes that 6, which makes that a 5. This 4 makes this a 9, not a 4, a 9. This 5 makes this a 4. This 4 makes this a 3. That makes that a 6, which makes that a 3. This can't be 5 anymore, so this is 8. This can't be 3. What are the remaining digits? This can't be 8, so this must be a 1, which makes this a 2, which makes this an 8. That means this can't be a 1, so this is 2, which makes that a 1, which makes that 2, which makes that a 1. This can no longer be orange. This can no longer be green. This is an orange. So therefore, where is the orange? It has to be here. These can't be green. This has to be a green. So this must be a 1, which makes this a 7. That 7 makes this a 9, which makes that a 7. The remaining digits here are 4 and 5, but this can't be 5, so this is 4, which makes that a 5. That leaves this to be a 9 and this to be a 4. And that's how you solve it. Yeah, that was a little tough, I will say. Particularly this part, right, where we got sort of stuck in this situation here. But we were able to actually understand it through this one, right? This one could not be 4. That was actually very key, because this being a 4-5 pair and with that. That was very key. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.